So welcome back to freezo Tech. This tutorial is a continuation of our Python series that we began earlier. In this tutorial we'll be going over inheritance in Python. So what is inheritance, you might ask yourself. So inheritance, you can think of it just like the normal English word inheritance. Means that you inherit certain attributes, properties or something like that from maybe someone who was there before you. That is what it's the same thing in Python. So you can think of it from a biological point, like we can inherit genetics from our parents. They pass those genetics down to us. Imagine that your parents maybe has a blue eye color, and maybe also you have a blue eye color, so you have inherited that. Or your parents has a dark skin and you also have a dark skin, you have inherited that. That is inheritance. Or you can think of in terms of like properties. Maybe you have inherited maybe some money or something from your parents. So it is the same thing, very similar thing in Python. So inheritance applies to objects, so we can inherit something from one class to another class and don't have to write the same code over and over again. So this helps us to prevent keep our code dry by inheriting properties that properties or methods that are already defined in another class instead of rewriting it again. Okay, so inheritance is one of the pillars, one of the main pillars of object-oriented programming. Okay, so not objects, rather it's other object-oriented program. That is a typo, so it's supposed to be object-oriented programming. So inheritance is one of the main pillars of object-oriented programming. I'm saying one of the main pillars because there are mainly four main pillars that we usually look at. There is the inheritance, encapsulation, polymorphism and abstraction. And by the way, the spelling of polymorphism is correct. I don't know why my editor says it's wrong, but it's correct. So today we'll be going over inheritance. We're also going over, in the future videos we might look at the other main pillars of object-oriented programming. So let's begin to see what inheritance is. So I've opened up my Visual Studio Code and I've created a file named as inheritance.py. So in this file we'll create a class. Let me use a class. This class will be called human race. Okay, so this class will have some methods. So we can say a human can walk. So what I'm basically making is creating a class of human. Let me just type out and then I'll explain to you to be clear when you see it yourself. So print. So this is walk. So saying this, you can say human can walk. Okay, so that is one. Let's create another method. You can say talk. So in here we take self. Remember every method or function, as a method within a class must have the self keyword. So in here we're going to print human can talk. Okay, so we have these two methods within our human class. So these are you can think of some characteristics of humans, because humans can walk and humans can talk. Okay, now whenever a person is born, a person inherits some of these characters from our human race, right? So if each time a child is born, he or she inherits these characters from a human race. So this is what I'm trying to represent here. So we'll create a class, another class called person. So person, so person I'll just pass right now. So I have created a class person, but this is just a normal class. So if I make an object of it, let's say my person is James. James is a person. Okay, now if I try to print, if I try maybe to get some methods of James, you can see we have no methods related to James. Okay, so to actually have some methods related to James, we have to inherit those methods from the human class. So to inherit those methods, so right now if I type dot, you can see that we have no methods that we can that is attributed to this James object. But wait, I inherit this from the human race. So we have inherited from the human race. So all of these properties of human race has been passed down to person through the inheritance. So to inherit something, simply put parentheses and then you put in the class from which you want to inherit from. So this is, so let me this is this is a subclass, and this over here is the superclass, okay. So this is the parent, or we can think of like the parent class, and this is the child class. So this is the subclass and this is the superclass, because this is the superclass because it's the main, is the top, is top in the inheritance chain, while this is at the lower stage, means that this one inherits from this one. So this one is kind of like much superior to this one. So that's how you do inheritance in Python, by putting parentheses and then inside here you specify the class from which you want to inherit from. So by simply doing this, when now I look at some methods or attributes, we can see walk and talk have now been, we can access walk and talk, but this walk and talk have been passed down from the human race. So we have inherited human race because each human inherits his walking abilities, his talking abilities from the human race. So if I say .talk, you can see in here the class is just an empty class, but I have this method, and if I run it, we will not get an error and everything works just fine. So if I this should run. So let's see what the output is. So it can see, you can see that human can walk, but you can see in our class it is completely empty, but we can do this because we are inheriting from the human race class. So it is what we can do. That's how we can do inheritance in Python. Now let's look at something else. So but how does it work? How do we inherit from the human race? How does this work in the background? To understand this, we need to look at something else. This is known as the method resolution order. So the method resolution order, or MRO, is simply a hierarchy describing which class inherits from which class. Okay, let me just show you in Python and see what I mean. So I'll remove this. So in here I will just bring a print statement, and I'll type in help, and I'll type in James. Okay, James. So if I run this code right now, you can see we get this output. So this output contains information about inheritance, or the method resolution order. So let's see what is outputted here. It's saying help on person, which is our class, because James belongs to the class, okay, the class person. So the class person, you can see it's inherited from the human race, and it is a subclass. And down here we can find this thing known as the method resolution order, which I told you earlier. So we can see we have our, at the base, at the top of the hierarchy, we have the person class. It inherits from the human class, and all of these classes in Python, or objects in Python, inherits from the built-in .objects. Okay. So at the top we have the human object, and then we have the human race. Sorry, the person object, and then the human race, which we inherited from, and then the built-in objects. So by default, all objects in Python inherit from the built-in objects. So to understand this more, I have created a chart here. So how the method resolution order works. So we have our person class. So we have created an object of it, and we're calling the .talk method. So what Python will look within this person class. Does it have the talk method that you want to inherit or want to use? Apparently, looking in a person method, let me just minimize this. Looking in a person method, it's completely empty, means that we don't have the talk. Just type it out here, James.talk. Okay, so looking in our class person here is completely empty, right? So we don't have the talk method. So what it looks in itself, it doesn't have the talk method. So it goes higher in the hierarchy in the method resolution order. It goes to the class which it inherits from. In this case, we inherit from the human race over here. So it will go to the human race class, and then look for that walk method. So in the human race class, it finds the walk method, and it will use that. So if we print this, that's why we get human can walk and talk. Okay, so it goes up to the human the class, and finds that talk talk method and uses it. If it didn't find it there, it would move into the built-in objects and maybe to find it there. If it doesn't, you probably get an error. Okay, so the basic thing you need to understand about inheritance is that you look within the class object itself. If it doesn't have it, it goes to the superclass. If the superclass doesn't have it, it goes to the built-in objects, and if it doesn't have it, you probably get an error. So you can think of it like this. Maybe you're in high school or college, and a person asks you, where is your house? Maybe you don't have a house of your own, and then but in your brain you're going to ask yourself, I don't have a house, but my parents have a house, right? So I will tell them the location of my parents' house, saying that is my house. So you don't have it. If you don't have it, you look if your parents have it, and if your parents have it, you refer to that one. But maybe 10 years down the line, you have your own house. So if someone asks where's your house, you have your own house. So you don't go to refer to your parents' house, you refer to your own house. So that is the same thing here. So if you have a house, you refer to your own house. If you don't have a house, you look at the persons who you inherited a house from. So that's the same thing. Person will look within itself. It doesn't have the talk method, so it will go up in the human race where it inherited from. It will check does the human race have the talk method. If it does, it will use it. If the human race doesn't have it, it will go to the built-in objects and look for it there. If the built-in object doesn't have it, Python throws at you an error. So that is what the method resolution order is, and that is how it works. Okay, so I hope it was clear. Now let's move on to overriding variables. Overriding variables. So we can override the variables that we inherit from our parent class or our superclass. So you can, moving down here, I've just show you the method resolution error. You can see here data description inherited from human. So the data that methods inherited from the human race. You can find we inherited two methods. I've already discussed that. Let's look at the we didn't inherit any variables, but we have inherited two methods. Okay, now let's make maybe all humans, they have an average height, which is maybe, let's say it be a string, maybe 6 feet. So all humans have an average height of 6 feet. Okay, let me just comment this out for now. So in here I'll just try to print James dot average height. You see we have that already. So if I print James dot average height, you see our average height is 6 feet, but this height we didn't specify within our person object. You can see this class rather, it's completely empty, so it is also inheriting that. So let me just print out the method resolution order again. So I just comment out that part and I run this. You can see that in the previous part we did not have this data and other attributes inherited, but now we have it since there's an attribute inherited. So you can see we have an attribute or a variable named as average height, which we have inherited from the human race. So inherited from the human race, average height. So we have inherited average height from the human race. Now to understand method resolution order more, I have told you that first the class will look within itself. If it doesn't have it, it will go to the class from which inherited or from the parent class. So in here, maybe in the future, maybe humans became taller, right? So they have of 12. 12 is too much. Maybe it's 8 feet. Okay, 8 feet. Okay, now if I print now, comment all this, and then I comment this. So let's run this and see what we get. So we get 6 feet. Did I get the spelling right? No. So I'll make the spelling right. So let's run this again. So we get 8 feet. But how did we get that? So that's what I have told you about. So at first the object will look within itself. Let me just bring back this diagram. Person, when you're trying to, James is a person of the class. James is an object of the class person. So we are trying to access its average height. So person class will look within itself. So does it have average height? Yes, it does. So it uses that. But if it didn't have it, it will look for it within the human class. So if I remove this comment out this and put in a pass, let's see what we get. This time we will not get 8 feet, you will get 6 feet, because it is going to, it doesn't have it within the person class, so it will go to the human class and find that over there. So that's how another way you can do, how you can understand method overriding and inheritance. So basically the person who is inherited look within itself. If it doesn't have it, that's when it go to the hierarchy where the person inherited from and look for it there. So if I run this right now, we should get 8 feet, because we have it within the person class. So you can override variables. So if you can override variables, you might ask yourself, can you override methods as well? Yes, we do, and this is known as method overriding related with polymorphism. We'll do that in the probably in the next tutorial. So now let's move on to the super keyword. So a super keyword is a keyword used in Python that is used to access the methods of the parent class or the super class. So for example, let's in here we can say I'll just create here a constructor. Let's go in it. So this constructor will take in a name of a person. So instead of saying human.works, so say self.name. Let me just type this, I'll explain to you. So if you say human.work, we don't want it to say human.works, we want to say a specific human or the person who is working. So you can say maybe James can work, Jane can work, Mary can work, because all of them, they are humans. Okay, so in here I will say self.name. So you can say self.name.work. So we just also do the same thing here, an S string. Yes, okay, an S string. I'll say self.name. Okay, so right now if we get an error here, right? So we need to so at the point of creating the object, we need to pass in that person's name. So you can say here James. Okay, so you need to create a constructor to accept that. In the last tutorial we have talked about constructors, and if you didn't know what a constructor is, you can go and refer to that tutorial. You can see Python the Visual Studio Code has already filled in that for us, but I'll just remove it and explain to you. So in here we'll take in the self keyword, and then we'll take in the variable name. So we'll say if we say self.name here, this won't work because we're inheriting from the human race, and that actually name is not used within this class, but it is used within the super class, which is a human race. You can see we're using that name over here. So you can say James.work and James.can talk. So you need to pass that variable into the super class. So to do that, that's why we use the sup keyword. So this is sup dot, and then here we can specify the method or the attributes that we see. We can work with the talk, the walk, and then the average height, but this will only be dealing with the constructor. This is a method inheritance, which we'll talk later on in the next tutorial probably. So if I type in your name, so I have passed this name that we have got in here, I have passed it into the super init class. So this will not be used within this class, but it is passed to this class. So we did this by using the super keyword. If you don't understand this, no, don't worry about it much, because if you go over method overriding, this will become much clearer. But just know that we use the super keyword to access methods of this the parent class or the super class. So now if I run this right now, we can change some things here. You can say talk. So let's run this and see what we get. You get James can talk, like that. Okay, can talk. Okay, so if we run this right now, we're getting James can talk and so on. So we shouldn't put a print statement here of these braces. So run this, we can see James can talk. So that's how we can do it. So if we create another object here, maybe say copy, Ctrl V, this is Mary. Let's say Janet. Okay. Janet. So you have, so if you run this right now, if you run for Janet, so if you run this right now, we can see Janet can talk. So that's how you can use the super method to access other methods, other methods within the parent class. Now we'll go over this in details when we talk about method overriding. So let's continue. So what we're going to look at now is multi-level inheritance. So multi-level inheritance, we are inheriting from a multi-level, because think of it like a generation. There is your grandpa, there is your father, and then there is you. So that chain from your grandpa to your father to you, that is kind of multiple inheritance, because your grandpa has passed on some features to your dad, and your dad has passed those features on to you. So this is a multi-level inheritance. Okay, but if you inherit from your dad directly, that is not non-multi-level inheritance. But if you inherit from your multi-levels, that is known as multi-level inheritance. Okay, so to understand this, I'm going to create another class in here. So a person can be male or female, right? So let's say a class, this is male, and then let's say let's have in here some functions. So you can say male, what characteristics of male, maybe has a beard, maybe something like that. They can just serve keyword, so you can print here male as, no, we just print as beard. Okay, so this is one of the characteristics. So this male, they're humans, right? So this is a human, so it's inheriting from the human race. And then person is male, so we can also create a person object for female, and then we create an object for female, and then we also do that way. So what we do, if you want to create for female, also you create a class like this, name it female, and then change the properties, also iterate from humans, because both male and female both are humans, so they are inheriting from humans. So if I pass in a person, I inherit from person class. Now we inherit from male, okay, because we are creating a male person, which is James. So let's remove Janet. So a male person name is James. Okay, so what is happening here is that, let's pull this diagram and explain to you. So the human race passes some features onto male, and then male has its own passes those features onto person, and that person happens to be James. Okay, so if we say James can talk, humans can talk, right? That attribute, that method is within the human class. So person will look for it within the person class, it won't find can talk over there. Will look for it within the male class, it won't find can talk, so it will look for within the human race, and the human race can talk. Okay, so that is the method resolution order, and that's how it works. So if you run this code right now, if I just say up here, say James dot, it's capital James dot talk. So if this will still work and will not get any error, and you can see James can talk. So it is the same process. So this has been passed on to the super class. Okay, so let me move this here, it will be a bit confusing. Okay, just remove this. Okay, so now that's where we are right now. So we have James person who can talk. We just remove this will just be pass. Okay, so that's where we are. So that is how you can do multi-level inheritance in Python, whereby the male class inherits from the human race, and the person inherits from let's actually call this male person, and then this is a male person. So the male person class inherits from the male, right, male class, and then the male class inherits from the human class. Okay, so all the attributes of of the human class has been passed to the male class. So to see this, I'll just comment all of this out, and then down here I'll create male. It will be in male. So if I say male dot, we can see it male has a height, has a beard, can talk, can walk. So if I take walk, you see, if you run this code right now, we get an error, missing operational arguments, name. So just come over here, remove all of this. Okay, I'll remove all this, I'll save this, and then I'll run it now. Male object has no attribute name. Okay, so it's supposed to be human, and this will also be human. And remove the f string, So this is how it works. So the human race passes on those features, can walk and can talk, passes on those features down to the male race. So now if you write, and so the male race has all those attributes of the human race. So if you say can walk, you can say human, can talk, which is male. Okay, so now all those attributes have now been passed on down to this class over here. So these two are our male class. So now if you create a male object, male can talk, and also we have male that has beard. So it takes a combination of both attributes from the both male and the female, and the both male class, which is has beard, and plus these other methods and attributes. Okay, so to understand, if I run this code now, it should add has beard because James is male. Okay, so to understand this more, I will just uncomment out this, and let me comment out this. So let me run this again, and you see the method resolution order. So in the method resolution order, we can see at the base we have the Python built-in objects, and then we have the human race, and then we have the male, and then we have the person. So this person class inherits from male class, and male class inherits from human class. So if you look, we have also we have created also those variables, and if you look at the methods inherited from, you see here we have methods inherited from human race, which are these methods. We also have methods inherited from the male race, which are this one. So it inherits methods from all the other previous classes. Okay, so I hope you understood it. So person inherited all the attributes and properties from male, and male also inherited all of this from this human race. So the human race passes down those attributes and methods to the male race, and the male race passes down to this one. That's why if you look in here, you can see we have inherited it both from the male class and the from the human race class. That is how we do multi-level inheritance in Python. So let's move on to other parts. So in this part we'll be talking about multiple inheritance. So multiple inheritance is basically inheriting from two other classes. So you can think of it like your mother and your father. You inherited some features from your mother, and you inherited other features from your dad. So this is multiple inheritance. And in other programming languages like Java, multiple inheritance isn't supported, but Python supports multiple level inheritance. So if you do not multiple inheritance is, I will just explain. So here I'll delete this method. So now so male person is going to inherit from male. So if I uncomment this, let me comment out this, and then I uncomment this. So if we try to print can talk, this we should get an error. We will get an error saying that the male person has no attribute to talk, because it only inherits from male class, and the male class has no talk attribute. So to solve that, we need also to inherit from the human race. So you can just say human race. We also inherit from human race. So if I run this code right now, you can say human can talk, so everything works fine. So now we have inherited from two classes, the male class and the human race class. So this is, instead of using a multi-level inheritance, this inheriting from this and then that, maybe just want to inherit directly from these two classes. That's how you can do multiple inheritance in Python. So to explain to you how multiple inheritance work, so we have the male and the human. All of them are passing down information to the person class, the male person class. So the male person class is inheriting from both male class and the human class. So this is multi-level inheritance. You can think of this like your dad and your mom. Both of them pass on features onto you. So that is known as multi-level inheritance, and that's how we do multi-level inheritance in Python. So this is how we can work with subclasses, superclasses, multiple level inheritance, multiple inheritance, and so on. So this brings us to the end of this tutorial. If this tutorial was helpful for you, please don't forget to like, to share, and to subscribe to my channel. If you have any question regarding object-oriented and what we have covered so far regarding object-oriented programming, you can follow me on Instagram at freezo, or you can leave a comment in the comment section. I'll do my best to get back to you. If you have any suggestions, you can also follow me to the same platform, Instagram, or leave a comment in the comment section below. So thanks for watching. See you in the next tutorial.